Okay, today is called conditional probability. And just a quick reminder, if I said I want to have a situation where I have only one girl, well then, would that work? It's girl, boy, boy, yeah, that worked. Would this one work? Okay. Only one girl. Is there any other ones that have only one girl? Yeah, it's only one girl. Very good. Okay. So those three all they're what I want. So you add them together and you put them on top of a fraction. Probability is what you want for what's possible. So what I wanted here was that and that and that. Only one girl. Okay, so then that would be 1 to 2 plus 1 to 2 plus 1 to 2. I could add them all up there. Or I could say 0.122 to the third power. No, wait, that's multiplying. Oh, sorry. I got to add them. Okay. Okay. So I'm going to actually add them. 1 to 2, 1 to 2, and 1 to 2 would make 0.366. Now, what's possible? Think 100%. You get dividing by 1 doesn't really do anything, but if I'm going to stick to probability, it's always what you want over what was possible. Now, here's the thing. For today, conditional probability, we put conditions on it, and that changes what's possible. All right, I'm going to give you an example then of one like that. Remember, what you want or what's possible. Given that the first kid is a boy, what's the probability it's going to be boy, boy, girl? Given the first kid is, what did I say before? A boy. What's the probability it's going to be boy, boy, girl? Okay, now here's the key to this. When I say given, I have just changed what is possible. Do you get as soon as I say given that it's a boy first, that this whole rest of this chart is impossible then? If I say it had to be a boy first, then I've changed what's possible. Now only these things are possible, and they get added up, and they go, those are now what's possible. Okay, now, I could do this the fast way or the slow way. And I like the fast way. They're going to add up to that. And all the things I crossed out, what do you think they added up to? 0.51, what they would have added up to. Okay, so, since all of these things, okay, if they're off a tiny bit, take it without just one problem. Do you think that they actually came out to exactly 117? No. So, yes, it can be off a smidge based on rounding. And that means you really shouldn't round until you hit the final answer to the question, because it can throw things off of it. You know what I'm saying? So these numbers should really be written all the way out. 1170359 or whatever. Yeah, you should write them all the way out. I know it's a pain, but unless you want to lose a half a point for rounding, which on a 10-point or 15-point test, it's a lot. You don't want to lose that half point. Don't round. Shut that door for me. Actually, not you. You get the foot. How about you? Thank you. All right. So, would you first add these up, and hopefully it comes out to 0.49, and if it doesn't, the only reason it's off is because it rounds a maximum on the bottom. It's totally okay to just use 0.49. In fact, if anything, it's more accurate because I know it's supposed to add up to 0.49, and if it's off, it's probably around. Now that I've done my given, notice my given changed my denominator. It always does that. Given changes the denominator. Repeat, fill in the sentence. Given changes the in your head, because you're going to get a bunch of givens today. That's the whole point of the lesson. The top is actually just the same as that. The top isn't changing. Conditional probability, the conditions you set are the givens, and the givens change the denominator. All right, so now the top. Well, some of you might have been just asking, why can't you just use BBG? It's right here, 122. Because you got to divide that by what was possible. 122 was assuming there was only a 49% chance of a boy, but now we know it's actually a 100% chance of a boy first. So that obviously changes your probability. It's not 122 anymore. You divide it by what's possible. Possible was the 0.49. In the end, final answer, 122 divided by 0.49. Somebody with a calculator tell me what they came out to. 0.122 divided by 0.49. If two people do it, that'd be awesome, so I can check them. What did you say? Did I have 24897? Did I have that part right? Okay, good. Then I'm going to round to 3 decimal places, which is what you usually round to, and it's going to be 248. True or false? False. Because the next number should round up. Was it 24897? Is that right? Is that what your calculator says? Okay. It says 24897, I'm pretty sure. And that means I look at this number here, and if this number is 5 or bigger, it tells me to round up. 249. 24.9% chance of that happening. Okay, moral of the story. You figure out what's possible, that goes on the bottom. You figure out what you want, that goes on the top. What you want over what's possible. From the beginning, that's the definition I was telling you. All right, so now I want to clear off my board here, and I want to give you a new question. Given that the second child was a boy, then what's the probability of boy, boy, boy? You might be tempted to just say it's this. You'd be wrong. That's part of your answer. What you want over what was possible. This one I would recommend you simply add up all the options. If you have a better way, test it against that and make sure it actually works. In my world, I'd pick all of these options here where there was a boy second, not all options. This is another option with a boy second. That's an option with a boy second. And I got to know all the ones that are possible. And I'll put them on the bottom. I'll pause while you work on that. Okay, we're back to the pause. And here's what you should have done. You should have found all the ones that had a second child boy, which would be that one has a second child boy, because the second letter is a B, you know. And this one has a second child boy. And this one and this one. And you added up those 4. Raise your hand if you added up the right ones. Okay, good. And those go on the bottom. And then what you wanted was boy, boy, boy. So then that's this one. And that's 0.117 divided by what all of them added to. Now, it's not so easy to tell what they all added to. You cannot do this. That wouldn't work. That would that would be a tragic mistake. So in this case, you just simply have to add the 4 numbers up, unless somebody found a genius way to do that. But it certainly wouldn't be adding the 49 and the 49. That means that it was a 90-some% chance, and it wasn't then. All right. So anyway, just add up the 4 things. Can somebody tell me what that bottom number was? Yes, sir. Anybody verify 488 was correct? Okay, good. And when you get the final answer, divide those two. What's that one? Anybody verify that one? Good. So then, I would probably round that to 240, right? Get that number right there. is telling me go up to 0.240. Final answer, 24% chance. Okay, you can tell these probabilities are getting more difficult. This is about as hard as it gets. There's just different situations. You've now learned to handle a situation if you have a tree diagram. Now, what if you don't have a tree diagram? Well, actually, almost every probability problem we have, there's like 3 more weeks, could be made into a tree diagram. It's just that it takes forever to make a tree diagram for every problem. So we have other ways that are faster than tree diagrams. But I just want to give you hope. If it makes you feel complicated, it doesn't get way more complicated than this. It's just that there's other situations. You have to know what type of a formula or process to apply, but they aren't going to be much more complicated. Yes. Yep. I got you. 488 is close to 49, but it's now. Is it possible it's only off by the 0.02 for rounding, or 0.002 for rounding? I suppose it's humanly possible. I just don't want to. Here's what I really didn't want you to do. I didn't want you to use. See, a lot of people are going to say these two added up to this, and these two came from this, and so I add up those two 49s and get 88. Let me think. 49 and 49 would be 80. 98.98. Obviously, that one. Yes, sir. Okay. You took this and you added these together and then you multiplied by 2? Oh, multiplied them together and then multiplied by 2. Interesting. I don't know if that's going to work. You know, like there's all kinds of crazy ways to get these answers. And I can't, you know, it's almost impossible to, like, know if that's going to keep working. I can only tell you that the strategy I showed you will keep working. Yes? Okay, wait. I know what you're saying is making sense. So if I replace the what? Boy, girl, boy, that one. You're replacing that with what? Boy, girl, boy. Why am I replacing it? Why do I want to replace that one? Oh, I see. So if this were to replace from there, this one replaced by boy, girl, which is this one, to go there. I gotcha. Then they would all add up to not that 49, no, not the one I took. It actually would add to that 49, which is, I know it seems like it's putting here a different number in a different place on the chart, but cool. I didn't notice that. So maybe there was a way we could have done it, but here's the bad part about this first part of the chart. That's supposed to represent the first choice, and the second child was a boy. So I know it's the same concept. I get it. Okay, but I want a way that'll always work for you. And if you add up all the things that are possible and you put them here, you'll be good. Now there are other ways to do it, but I'd hate to have you depend on them. Down the top. All right, so let's move on. Actually, I think we're ready to move on to. I didn't use the smartboard for today because I wanted to get into the homework a little bit quicker. So I'd like to just start on some homework problems. And everybody find your homework. It's in here. Conditional probability. We are doing the odds for tonight. Oh, great. I'm going to pause for a second. Okay, we have found a way to put up problem 3 of the homework. So let's start this one. 3 seeds are planted, each one having an 80% chance of germination. Now I get some of you want to make it go like, here's my 3. I wonder how I can write it. Oh, maybe you can draw it. If you make 3 triangular sets, okay, Now that is a very common mistake answer because you're thinking those are my 3 seeds. What you should be thinking is, can you erase that? Make a double, and that's your first seed. And then, after that seed is done, the next seed is the next column. Okay, so you make a V up here, and another V down here. That is seed number 2. The last column will be seed number 3. There, 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 and there. Okay, now at this point, I know some of you are going to be like, I can't do this on the iPad because my iPad's broken right now. What I would do if I were you, I know it's not your iPad, it's a school site, but I would grab a piece of paper. If you can't get this up on your screen, grab a piece of paper, please. And just copy the chart. You can use that. I won't make you like redraw it on your iPad later today. But get the chart copied down. I guess you could always do it on Notability because your iPad may be schooled you may be dead. The iPad Notability should be. All right, now we just need to figure out the answer at the end of each branch. Could you put a 0.8 here and a 0.2 here? Awesome. Let's come back out again. Thank you. Just like that, on each of your branches, you need to label a 0.8 and a 0.2. And at the very end, when you multiply them, you get a decimal that's, I would recommend you go out like 6 digits. You don't want to round it to the very end. So when somebody does 0.8 times 0.8 times 0.8, or you could do it even faster by saying 0.8 to the third. Yes? 0.512, and it rounds to that automatically, I guess. So would you put that right up at the very top class? Your handwriting is excellent for an iPad. All right. Now the next one's 0.8 times 0.8 times goes down at the end. 0.2. 0.8, 0.8 to 0.2. Got that one? Okay, keep going. Is that automatically rounding itself too? Okay. All right. And this one, next one's 0.8 and then a 0.2 because it goes down. And then a 0.8 again. Isn't that going to be the same exact thing? Just in a different order. All right. And this one's a 0.8 and a 0.2 and another 0.2. Now this next one is a 0.2 and a 0.8 and a 0.8. And I think we already had that combo. Awesome. And this next one's a 0.2 and a 0.8 and a 0.2. We had that combo also. And now for the last set. 0.2 and then a 0.2 and then a 0.8. We've had that before. And the very last one we haven't had before, 0.2 and a 0.2 and a 0.2. Okay, this is the most important part of the job. Once you've got this done, answering the rest of them is going to be what you want on the top divided by what was possible on the bottom. Okay, so part A. What's the probability that all 3 seeds will germinate? That is what's the one with all 3? It's at the top there. Right? 80% chance, 80% chance, 80% chance, so it's 0.512. Technically, it's 0.512 divided by what was possible, and all things were possible. So, you're showing it very nice. Okay. Exactly. 2 will germinate. We got to go back and find where there's 2 that germinated. The top one is not exactly 2. So we throw out 0.51. The one underneath it, 0.128, has 2 germinating. And you know what would be a fast way to find the other one? All the other ones are the same as it, right? So wouldn't it be safe to say that all the other ones that have 2 things germinating would have 2.8 and a 0.2, and therefore be the exact same answer, and therefore be 0.128? Does that make sense? All right, so they're all 0.128. There's a whole bunch of them. Was there 3 of them? Times 3. Or you could have added 0.128 plus 0.128 plus 0.128. We divide by what's possible, and everything is possible, so you're doing it right. Keep up the great work. All right. Okay. Now let's go to E as an element, because that's the first one where it's truly a conditional probability. As soon as they say given, you notice, now they didn't say the word given, but it's kind of like that. Given you notice that at least 2 seeds have begun germinating, obviously that means at least 2 already germinated. That is a given. That changes the bottom. It's not out of 1 anymore. Do you get, if 2 of them have germinated, then we have to look for all the ones that are possible. Is the top one, is that top one possible then? You know 2 of them have already germinated. We just don't know about the third one. Do you get that the top one has 2 of them that have germinated? And it might have 3? We don't know about the third seed yet? That's what they're trying to say on that. They're not trying to say 2 germinated. They're trying to say we know for sure 2 have germinated, but maybe the third one. So that is possible. How about the same one that's impossible? The bottom one. That's impossible because it has 3 of them not germinating. Could you cross that one off? We can always undo it in just a second. All right. And how about the one right above it? That one has 2 of them not germinating. That can't be possible either, right? The next one up also has 2 of them not germinating. So that's not possible. We could do it from that perspective, right? And just cross off the ones that aren't. All right, you get the idea. Find all the ones that are possible. Go on the bottom. What you want is, what is the probability that all 3 will germinate? We already had that one with 0.512. But it's not the answer all by itself. 0.512 is what you want, so it goes on top. So the hard part isn't the top. The top is 0.512. Bottom part. The bottom part, we have to add some stuff to figure out all the ones that are possible. Add up the ones that are possible. We're not done there, but I'll let you finish it from there. And that's all the help that I have for you on today's. Today it's the odd problem. Yes, sir.